Starting with circle ABC, take a point D outside of it. We can draw two lines from D to the circle. Let one of them, DB, be tangent to the circle, and let the other intercept through the circle. We want to show that AD times DC is equal to DB squared. Euclid uses the term convex circumference in this description of the proposition, which is this part of the circumference. There are two cases. The first is if AD goes through the center of the circle at F. Join FB. Since DB is tangent to the circle, angle DBF is a right angle. Now AC is bisected at F and CD is added to it, so, by proposition 2.6, AD times DC plus FC squared is equal to FD squared. Triangle FBD is a right triangle, so FB squared plus BD squared is equal to FD squared. Therefore, AD times DC plus FC squared is equal to FB squared plus BD squared. FC is equal to FB, being radii of the same circle, so FC squared is equal to FB squared. We can thus subtract FC squared from both sides to get that AD times CD is equal to BD squared. That's the first case. The second is when AD does not go through the center of the circle, like so. Take E to be the center of the circle, and draw EF to be perpendicular to AD. Connect EB, EC, and ED. DB is tangent to the circle, so angle DBE is a right angle. EF is perpendicular to AC, so it also bisects it. Notice also that AC has been added to with CD. So again, proposition 2.6 says that AD times DC plus FC squared is equal to FD squared. Add FE squared to both sides, thus AD times DC plus FC squared plus FE squared is equal to FD squared plus FE squared. Triangle DEF is a right triangle, so FD squared plus FE squared is equal to ED squared. And triangle CEF is a right triangle, so FC squared plus FE squared is equal to EC squared. So we have that AD times DC plus EC squared is equal to ED squared. EC is equal to EB because they are radii of the same circle, so EC squared is equal to EB squared. Triangle DEB is a right triangle, so EB squared plus BD squared is equal to ED squared. Therefore, AD times DC plus EB squared is equal to EB squared plus BD squared. Subtracting EB squared from both sides gives that AD times DC is equal to BD squared.